In this section, we're looking at adding and subtracting decimals. Very important skill in mathematics. The principles for adding and subtracting, right? Knowing how to add or subtract, those principles are the same, even when you're dealing with decimals. The difference, of course, now is you have a decimal point and you have to account for the details, with the decimal point. And so in your book, they start off by talking to you briefly about what we talked about before, which is taking a number like 2.34, being able to write that as 2 and 34 hundredths, right? And you have that, and it's adding to 5.25. Now you can just go ahead and add these two, right? 4 plus 5 is 9, 3 plus 2 is 5, and then 2 plus 5 is 7. So that's 7.59. But you can also technically do that same problem off to the side here. You can write that as 5 and 25 hundredths there. And so we could use the principle we learned before of mixed fractions. This and this will add. You would have 2 plus 5 plus 34 over 100 plus 25 over 100. So that becomes 7. And then those two numbers here are going to add. You're going to have 59 over 100. So we get the same answer, but one of them we just added them using a vertical format of decimals, and the other one we used 7 and 59. 7, we got that using the mixed fraction approach. So that was one example there using the showing two different scenarios. Moving forward, you don't have to worry about using the mixed fraction approach. You can just line up the decimals and work that way. So if you have 2.34 like we had in your example here in your book plus 5.25, that approach will work just fine. So to add decimals, you place the numbers in a vertical format, and then you add the numbers again using the principles that you learned from whole numbers. It is important that the decimal goes in the same place. So if you have something like 259.234 that is trying to be added to, let's say, 5.232, notice that, again, I line it up so the decimal points are in the same spot, and then I can go ahead and add. So we have 6, we have 6, we have 4, we have 14 here, carry 1, and then 264.466, right? So that's just showing you an example. Line the decimals properly, and then you can add them. 2.864 plus 3.029. Again, we just go down and add. As you've learned, if you get a number that is greater than 10, you carry that over. That is the same principle that you learned earlier on. So in this case, we have a 3. 4 plus 9 is 13. We carry 1 over there. 6 plus 2 is 8. Plus that 1 is 9. 8 plus 0 is 8. And then we have 5. So 5.893 is the way we get that answer. So that was the beginning of the chapter on page 359 from Redwood's Pre-Algebra. The next question here, next to example 2, says Alice has $8.63. We can just say she has, let's say, $8.50 in her purse, and Joanna has $2.29. So let's update the question here. Imagine if Alice has $8.50 and Joanna has $2.25. So those are the amounts they have. If they combine their money, what is the total? So in this problem we've set up, we know that 0 plus 5 is 5, and then 2 plus 5 is 7, and 8 plus 2 is 10. So they have $10.75. Notice that this is a good skill to have when you're dealing with money as far as decimal addition. And so your book goes on to talk briefly about another example. They give you example 2, similar to the one I just did, using money, a money example. And then they talk about an important observation. Adding zeros to the end of the fractional part of a decimal number does not change its value. That's very important to note. So deleting trailing zeros from the end of a decimal number does not change its value either. So 7.35 or 7.35000, the same value. But you might be wondering, why do I need to deal with zeros at the end? Because sometimes it is helpful to add zeros to solve problems, to make problems work out better. So look at the situation. We have 9.7 plus 15.86. So 9.7 plus 15.86. But if we're going to add these two, imagine if I put a 0 at the end with the 9.7. Now it's kind of nice because 0 plus 6 there will be 6. 8 plus 7 is 15. You carry 1. 9 plus 5 is 14 plus that 1. So that's 15. You carry 1 over there. And you have 25.26. Adding that 0 can be helpful when you're adding decimals and even when you're subtracting decimals. With example 4 in your book, or just with general practice, if you have more than 2 decimals that are adding, the same principle will still be at work. You just go ahead and line up the details. All the decimal points have to be in the same place. And then you go ahead and you can fill this in with 0 and 0. You fill it in with 0. And then you basically go ahead and add each column. So this would just be 6. This would become 15, carry 1 here. And then 9 plus 1 is 10. Plus this 2 is 12. Plus that 9 is 21. We put a 1 and carry over a 2. 2 plus 2 is 4. Plus this 4, that's 8. Plus 3 is 11. You carry 1 over. 1 plus 1 is 2. Plus that 3 is 5. So 51.156. Now notice that I didn't put anything in front of this 4, but you just go ahead and add these numbers down, right? That's how we work with adding decimals. So that is the first part of this section. Now let's look at subtracting decimals. So subtracting decimals. Subtracting decimals. With subtracting decimals, the principles again are the same. It's important that you line up the details, line up the decimals in the same spot, right? So we have that's lined up, and now we subtract. 6 minus 5 is 1. 7 minus 9, of course, that won't happen. We have to borrow from here. We bring that over. That's an 8, and so this is now a 7. We borrow from here. We bring it over there, and then we have this is now 4, right? So then you have 19.81. So subtracting decimals, similar principle you've learned before. It's still a good skill to remember adding those zeros. So we're going to do an example now where we have to add zeros in order to work with subtracting decimals. So when we have 15.2 minus 8.756, we can add zeros at the end there. And so basically, we can't do anything here first. We can't do anything there. We take a 1, we borrow from there. We bring it over here. Cancel, that becomes 9. We bring that there. 10 minus 6 is 4. 9 minus 5 is 4. We need to borrow from here. We bring that over. We have a 4 also. And now we have 14 minus 8, which is 6. So that is how we work through this. Notice that we added those zeros and that helped us. So adding the zeros can be a very good tool. Now, what do we do when we're dealing with negative decimal numbers, right? You have to remember that, integers with general principles of integers, no problems there. We discussed that before. But now what happens if you have decimals that have signs? There are situations where they have like signs and situations where they don't have like signs. So like signs would be situations like negative 2.5, right, plus negative 2.5, something like that. Well, that's just the same thing as negative 2.5 minus 2.5, which is just negative 5.0 or negative 5, right? So if you have a situation like that, that is where you have like signs. But then there are situations where you have unlike signs. Now, a note for the times where you have like signs. Notice that when you have like signs, basically part of what you're doing is you're technically just kind of adding those numbers together and putting a negative at the end, right? So it's almost like you just had 2.5 and 2.5 added together, and then you got 5, and then you put a negative because both of them were negative to start with. Now, what do you do when you have unlike signs? When you have unlike signs, things get a little interesting, right? So you have a situation like negative 8 plus 5.74. So negative 8 plus 5.74. There's different ways to handle this. One way is technically to take out that negative, and then you would have this situation before you. What I did was I extracted a negative out, right? Because both of them, technically, we can extract that negative. If we're to distribute that negative back in, it'll give us the original equation or the original expression. So in this case, you have 8.00, you have 5.74. You can apply a subtraction, and then when you finish, you put a negative in your final answer. So let's look at this situation. Basically, we take the 5.74 like this. The 0 here, we had to borrow from the 8. We get 1. That's 10. So I'm basically just setting it up like if you had 800 minus 574. Imagine you had that situation. That's what I'm doing. Just keeping in mind that I have a decimal point. I have decimal points to work with. So 10 minus 4 is 6. 9 minus 7 is 2. and then 7 minus 5 is 2 as well, so 2.26. However, there's a negative weighting, so when this comes out, it becomes negative 2.26. So how did I solve this problem? I basically took care of the 8 minus 5.74. I treated it that way, and then I applied a negative at the end. So that's one way to do it. You could basically subtract the smaller number from the bigger number and apply a negative at the end. Imagine if you went into a store and you only had $5.74 and you were trying to buy something that was $8. So basically this is telling you that you're going to need $2.26 more to make it work. So that is how we handle that problem that I just finished. Let's look at another situation. Negative 2.384 minus negative 15.2. So if you have a situation like this, it's technically the same as negative 2.384 plus 15.2, which is the same as 15.2 minus 2.384, right? So if you have a situation like that, you can write out 15.2 and then 2.384 and then the zeros, right? Now, why did I move this to the front? Because the commutative property of addition allows me to move numbers around, and this number can technically be put in front, and it will be the positive number there. When the positive number is the bigger number, right? Of course, we know when it's positive and the other one is negative that the positive is, of course, the bigger number. But what I mean is if you had a situation like this, 2 minus 5, it's nicer, negative 2 plus 5, I apologize. If you had negative 2 plus 5, it's nicer to write it as 5 minus 2. It's just nicer and just works out fine and better. So you could do this. This has an answer. Of course, it's 3. But you might as well just rewrite it this way and get the same answer, right? So that's what we did over here. And you can go ahead and complete this problem for us using the principles you've learned from subtracting decimals. The answer to that problem will end up being a positive 12.816, but you can work out the details. So because this becomes 10, comes down, and then this becomes 9, and then this becomes 11 minus 3, and that becomes 14 minus 2. So order of operations, of course, are very important if you have parentheses involved. So if you have a situation like negative 12.8 minus and then negative 7.44 plus 3.7. If you have a situation like that, you need to take care of what's in the parentheses first, and then you allow that to come out and interact with the 12.8. So in this case, we have, again, remember what I mentioned earlier. So if you have this situation, okay, this is where I'm going to use a bracket. So then I'm going to do this. Okay, why did I use a bracket? Because I want to simplify this in here first. 7.44 minus 3.7. So that's going to be 4. This is going to be 7. This is going to be 3. This negative is going to apply now back to this. So it's negative 12.8 minus, and then inside this now, it has become minus 3.74. These negatives will meet and become positive, so it becomes negative 12.8 plus 3.74. And I'm going to use the same principle I used earlier, put a negative, and then 12.8 minus 3.74. Allow those to interact, and then put a negative at the end of that. So that would be, so you have 12.8 minus 3.74, right? And if we do that, we get 9.06. So then we apply that negative, and it becomes negative 9.06. So that's how we get to our destination for that problem. If you have any questions on fraction, addition, subtraction, please let me know. We're going to end with an absolute value situation, and then we'll go from there. So let's see. Moving on to the next one. This is our last example before we let you try some practice problems. So let's look at this one. So we have a situation like this, and an absolute value situation is being used. We basically deal with what's inside this first before we proceed. So we have negative 8.6. Again, we just leave that there. Minus, that's the same minus. And then in the absolute value, let's go ahead and take care of this part first. That becomes plus 8.32 absolute value, which is negative 8.6 minus, and then in the absolute value, I'm going to actually change the order of the problem because the 8.32 is greater than the 5.5, and it's just nice to write it out that way. Let's go ahead and subtract. So we have 2, and then this becomes 7 and 1, so 13 minus 5 is 8. 7 minus 5 is 2. So minus 8.6 minus and then 2.82. And now we have negative 8.6 minus 2.82. Why is it minus 2.82? Because this minus is the same one we brought from the beginning. It's the same negative there. In the absolute value sign, that's what's happening in there. But the moment you remove the absolute value signs, you have minus and then 2.82. So basically now we have 8.6 and 2.82. They both have the same signs. So we could technically add them together and then apply a negative at the end. So when we add them together, we have 11.42, and we apply that negative at the end. And we get negative 11.42 as a solution to the problem. So take it one step at a time. And if you have questions on it, let me know. This is a very important principle to apply in any part of mathematics, where you take care of what's inside first, work your way inside, take care of everything inside, and then apply things from the outside. Let me know if you have any questions, and keep up the good work.